Hello students, I'm going to talk about this problem in our review packet. So we've got a polynomial that's fifth degree, double zero at -1, 0 at x equals 2, and an imaginary 0 at x equals 1 minus I, and some information to help us find the a value. So let's go ahead and write down what we know. So x equals -1 is a double zero, so that means x plus 1 is a double factor. X equals 2 means x minus 2 is a factor. An imaginary root at x equals 1 minus I means x minus 1 plus I. And of course, if we know this, we also know x minus 1 minus I. So 1, 2, 3, 4, 5 roots. We don't know the a value, and that's where this is going to come in. And this is our p of x statement. So I'm going to multiply this out so that we have real factors. Coefficients are real numbers. We never want to leave it just like this, but we don't have to go all the way to standard form. So first let's multiply this out. We know that this is the same as x minus 1 plus I times, it's too many parentheses, x minus 1 minus I. So we can recognize that this is a factored difference of squares, so that means that together it's going to be x minus 1 squared minus I squared. If I expand this, I get x squared minus 2x plus 1. This is also plus 1, so I get a plus 2 here. And now the rest of my factors I can just bring down, squared, and then my a value, and this is my p of x. So now I know p of 4 is -25. So I'll use that. So p of 4 is a times 4 plus 1, that's going to be 5 squared. 4 minus 2 is 2. 8 minus 8. Whoa, wait, 4 squared is not 8. 4 squared is 16. Plus 2 equals -25. Well, this is 25, so if I divide on both sides, this is going to turn into -1. So I get a times 2 times 8 plus 2 is 20. 8 plus 2 is 10. Thinking ahead, that 10 times 2 is 20 equals -1. So a is -1/20. Now I can finally write my p of x. -1/20, x plus 1 squared, x minus 2, x squared minus 2x plus 2. From this, I know all of my roots and also my y-intercept I can find easily now. So part B, p of 0 is where my y-intercept is, -1/20 times 1 squared times -2 times 2. That's going to give me -4 times the negative, so I'm going to get 4/20, which is 1/5. Is my y-intercept. All right. And now find the values of x that make the polynomial negative is really what we're saying here. So I know that my roots are at 1 was a double root, so I'm going to either bounce up or bounce down. And then I had 2. Should I have -1? Whoops. Okay. Sorry. Let's call this one 2. -1. Here I'm going to bounce either up or down. 1/5 is my y-intercept. So if this is 1, I can have my y-intercept down at 1/5. And I have no other real roots. I know it's degree 5, so that's an odd degree. Normally that goes from -infinity up, but it's negative, so it's going to point the other way. So I'm going to have a bounce here, come through. We don't know where the imaginary roots are, but it might look something like that. So I've got some sort of shape that looks like this. Looking at this, it looks like for x less than 2 is where my polynomial is negative. But let's check it with a sign chart. So in my sign chart, I'm going to have x values and my polynomial values. So x and then p of x. And I want to look at values all around my roots. So I know that -1 is a root, so I want to look at values less than -1, and then between -1 and 2, and then I've got 2, and then I've got x values greater than 2. And that is what I meant to say here. Oops. So checking with the sign chart, I'm going to pick a value that's less than -1. So let's say like -2. Let's rewrite my polynomial. P of x is -1/20th, x plus 1 squared, x minus 2, x squared minus 2x plus 2. Really what I'm looking for is positive negative. So I'm going to plug in a value that's less than -1, but really all I'm thinking about is the term going to be positive or negative? I know I'm going to have a negative multiplied by a positive. No matter what I plug in, I'm squaring it so it'll be positive. Now if I put in a value that's less than -1, this is going to be negative. If I put in, let's test -2, so that would be 4 plus 4 plus 2, that's going to be positive. So negative times positive times negative times positive, this is positive, as we anticipated. I know when I put in -1, I get 0. Now if I put in a value between these, I'm going to pick the easiest value, which is 0. So I'm going to have a negative times a positive times a negative times a positive. So again, this is positive. Put in 2 and I get 0. And now put in a number bigger than 2. I have a negative times a positive times a positive times a positive. So for example, if we pick 3, 9 minus 6 is positive. So this ends up being negative overall. So this is the region where my polynomial is negative. I don't have to worry about testing anything else because I know that these are my only two real zeros, so I'm never crossing the axis again.